So today we will be doing IPv6 addresses. So as you know, since IPv4 addresses has gone obsolete, it has run out. Now IPv6 addresses are being used. So due to the limitations of IPv4, so IETF started the development with IPv6 due to the limitations of IPv4 addresses. So some RIRs, those who give the IP addresses, so they didn't have any IPv4. 4 out of 5 RIR was not having any IPv4 addresses. All the IPv4 addresses were depleted. The regional internet registry. So that's why the need for IPv6 addresses was there. RIR, they are the ones who are responsible for the distribution and management of internet number resources. Now, to remove the problems of IPv4, IETF came with ICMP version 6. That is Internet Control Message Protocol, which includes address resolution and address auto-configuration, which was not an element of IPv4 before. IPv4. Now, IPv4, we could have up to 4.3 billion addresses. But with IPv6, we can have up to 340 undecillion addresses. So which, you know why it's important to have so many addresses? Because now we have IoT, Internet of Things. So with Internet of Things, we put an IP address with nearly all devices. All smartphones today have got an IP address. Previously, phones didn't have any IP addresses. Now phones have IP addresses. Your refrigerator at home has got an IP address. On any device, you can put an IP address. This is the concept of Internet of Things. Everything can be connected to the Internet. So, let's see IPv6 addresses. They are 128 bits in length. IPv4 addresses were only 32 bits in length. Now IPv6, it's 128 bits in length. It's written as a string of hexadecimal values. Here it is. This is an example of an IPv6 address. What do you notice here? It has 8 parts. 8, 4 digits here, 4, 4, 4, 4, which comes to 32 digits. But it has 4 digits between the columns. These 4 digits here, this is called a hextet. So we have 8 hextet. Now IPv6 addresses are not case sensitive. So like here I have a B, capital B. If I put a small letter B, it's not a problem. If I put small letter B in it, it's not a problem because it's not case sensitive. Whether you put it lowercase or uppercase, it makes no difference. The device will understand the IPv6 address. Now IPv6 addresses can now accommodate 340 undecillion addresses. That is, the 340 is followed by 36 zeros. Now, when we talk about hexadecimal, hexadecimal, they are values that are representation from 0 to 15. In decimal, it's 0 to 15, whereas in hexadecimal, it's 0 to 9. Then the 10 is represented by an A, 11 represented by a B, 12 represented by a C, 13D, 14E, and 15F. So as you see, hexadecimal, we have 0 to 9, and then A, B, C, D, E, F. F is the highest. Now, if I have to, in IPv6 address, so I've shown you here how to write an IPv6 address. So it's divided into 8, all right? So here we can have 1E01, for example. We can have FF01. We can have ABC1. We can have 56EE. We can have FF01. We can have 000. We can have 11AA. And I can have 9BC2. So it's 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hextet. And this hextet, which is 4 digits, is represented in binary into 16 bits if we have to convert it to binary. 16. Each one of it will represent 4 bits. This we'll see in another video. Each bit can be converted to 4 bits in binary. Now, we'll write IPv6 addresses in a compressed format. Here we have an IPv6 address. So if I want to compress it so that it looks shorter, we have to reduce the notation of the IPv6 address. We have to compress it. We have some rules to follow. We have to omit leading zeros. Leading zeros here, we don't have any leading zeros, so A, B, C, D will be written same way. Here we have leading zeros. Leading zeros means that comes in front. Here we have 3 zeros, so I can put only 1 here. I'll remove the 3 zeros. 15 EE. AB, this is not a leading zero because it's found at the end, so this cannot be removed. Here we have 0, 0, 11. So here we're going to have only 11. All these 4 zeros can be represented by a 0, when FF0E. This is rule 1 applied, where I have removed the leading zeros. To compress it further, I go with rule 2, where we use a double column. When we use the double column, let's see here, we have 0, 0, 0, column 0, 0, 0. We don't need to put all this. We just put A, B, C, D. Column 1, column 15, EE. A, B, 0, 0, that's okay. 1, 1. Then these 2 zeros, we'll put 2 column, then we'll put FF0E. So now it is in a compressed format. This is in compressed format. So these zeros that has been repeating here has been represented by this double column. This double column can appear only once in your IPv6 address. Now let's say this one, we'll compress this one now, AB00. We have 0001. It will be represented by 1, 7 ABC, 11 EE, FF01. Now I have all these zeros here. I can compress when we have zeros appearing several times together. We just have to put double column. So this time I've put a double column here. So this is the compressed format. Let's see this one. This one we have 0 here repeating, 0 here repeating. And as I told you earlier, we can have only the double column once in the compressed format. We can't have it more than once. So for this one, we are going to write it either this one, column FFEE, ABCC, then I put 0, 0, column 1. Or I write it ABC1, column 0, column 0, FFEE, ABCC, column, when I put the 1 here. So there are two ways we can compress it. Here we have FE80. We have all these zeros here. 1, 2, 3, 4, 5, 6. So I'm going to put column, 1. So we put the double column to replace all this, to compress all the zeros together. Here we have all these zeros when we have a 1 here. So it's column, and I put the 1 here. So this is how we compress an IPv6 address. So I hope you've understood IPv6 address, how we write it. In my next video, I'm going to show you how I'm going to create a LAN, a network with IPv6 address. Thank you.